Hi everybody, it's Mr. Kinney. I'm just going to show you how to get started on this assignment, moles, molecules, and atoms. Up to now, we've been converting grams into moles and then moles into grams. So that's a pretty straightforward, just multiplying or dividing. Well, now what we're going to do, let me scoot over here. We're going to be going a different way. We're going to be converting from moles into how many atoms or molecules that you have. And when you convert how many moles you have into how many atoms or molecules, well, you're going to multiply how many moles you have by this conversion factor. And that conversion factor is going to be Avogadro's number, 6.02 times 10 to the 23 particles, which will either be, if you're talking about atoms, or in this activity we'll be talking about molecules, 6.02 times 10 to the 23 molecules in 1 mole. Okay, so let's see, or if we give you the number of molecules or number of atoms, what you can do is, to convert that back into moles, you're going to divide the number of atoms or molecules by Avogadro's number, 6.02 times 10 to the 23 with 1 mole over. And these become the conversion factors, because remember, stoichiometry is just a series of conversions, and when you're going from molecules, number of molecules, to how many moles, you divide by Avogadro's number. So, first problem we're given is 3.612 times 10 to the 24 molecules of CH4. That's methane. So to set this up, since we're going molecules to moles, we're going molecules to moles, we're going to divide by Avogadro's number. I'm just going to go ahead in this problem, use this as the given, and I'm going to set up, this is just a one-step conversion factor. Now I'm using this format here. You could just as easily put your brackets like this, but it's just quicker and easier to just draw a line, and when we do a lot of conversions. So let's see. We're dividing by the number of moles here, so 6.02 times 10 to the 23 molecules, M-O-L-E-C, I'm going to abbreviate that molecules of CH4 in 1 mole of CH4. Now I got to be careful. You don't want to abbreviate molecules, because I'm kind of shortening it here. Don't use the same thing. I like using molec because I know that that's not a mole. Now we can cross off. So now we can cross off molecules of CH4 with molecules of CH4, and then to get our answer, you'll enter in your calculator 3.612. Most of you, if you have that EE function, now you do not do times EE, you will just enter 3.612 EE. A few of you have a button that's like this, times 10 to the N, or sometimes times 10 to the X. You can use that, but don't put 3.612, do not put times. You just push the EE button or the times 10 to the N button. It automatically gets all of this set up, and then after you push those buttons on your calculator, you just enter in the exponents. So 3.612 EE 24, that's how you'd enter that, or times 10 to the X or times 10 to the N 24, and that's going to enter it in for you. Then you're just going to hit the divide button, and you're going to divide it by 6.02 EE 23. That gets it set up. And then you hit equals, and you'll have your answers. Some of you have other calculators. You might have to push a button to get it out of exponent, but we've already practiced that. Now, the rest of these are set up the same. You're just going from number of atoms or molecules to number of moles, and you do that by dividing by Avogadro's number. Over here now, the middle part. We're looking for, find the number of atoms or molecules, and we're given the number of moles. So we're going from moles to number of atoms, and the conversion factor is you multiply by Avogadro's number. And it should make sense, because if you're going to number of particles, it's going to be a huge number. So in this first one, we've got 5.5. Always use a pencil. It's really a good idea. Moles of calcium carbonate, chalk basically. And if you like, we can put that fraction over 1. If you're still more comfortable using the parentheses, that's just fine. And then let's see here. So now we need to have moles down here, and we know that 1 mole of calcium carbonate is going to be 6.02 times 10 to the 23 molecules M-O-L-E-C. I'm going to abbreviate molecules of CaCO3. Don't get lazy. Now we can cancel. Cancel moles of calcium carbonate with moles of calcium carbonate. Now what you're going to get is 6.02 EE23 times 5.5. That's about 6. So your answer is going to be 6 times 6 is 36. Well, this is a little less than 36, probably 33, 34. And then times 10 to the 24 is what I think you're going to get. But work it out. You should get that. Lastly, so the next three are very similar. And this is, you can really think of this as really practicing doing your how to use your calculators. Find the number of oxygen atoms. Now we're looking for number of oxygen atoms. So we're going to start just like we did here because we're given moles down here. We're going to do the same thing. We're going to start like this, but then when we get to number of, when we get here to number of molecules, then we're going to do one more. We got to do one more conversion, and I'll show you how to do that. So, ready to go. This is what we're given, 10 moles of water, H2O, and 1 mole of H2O, and we did this, we said 1 mole of H2O is, well, just like before, it's going to be 6.02 times 10 to the 23 molecules, M-O-L-E-C for abbreviation, H2O. Don't forget to put the H2O in there. And now, let me get my colorful pen. Moles cancel out, and what we've got is how many, we're going to have 6.02 times 10 to the 23 times 10. That's how many molecules of water. But now we need to figure out, in every molecule of water, how many atoms of oxygen. Well, here's 1 molecule of water, and it only has 1 oxygen. So we're just going to turn that into a conversion factor. We want to get rid of molecules, so we're going to say 1 molecule of H2O has 1 atom of oxygen. Okay, so because that's what we're looking for, how many atoms of oxygen. So we can now cancel off molecule of water with molecule of water. The only units we have left are atoms of H2O. So now you're going to be doing 10 times 6.02 times 10 to the 23. You don't need to worry about anything else. So be careful. How many oxygens do you have there? How many, now in number 11, every hydroxide has 1 oxygen, but look how many hydroxides you have. And this one here, every phosphate has that many oxygens, but we've got 2 phosphates. So how many oxygens altogether? So make sure you pay attention to that, because those numbers of oxygens are what you'll put, that'll be the difference in these. So practice away.